Hello, in this video we will look at a stress-strain graph for a ductile material such as a metal, say for instance steel. Okay, now so we have here stress which is in force divided by area in newtons per meter to the -2, and strain. Now strain has no units because that is simply the ratio of extension over original length, so the units will cancel each other out. Now the first point P is a limit of proportionality. Okay, I'll put it here. Limit of proportionality. Okay, up to that point the material will behave as Hooke's law, so stress will be proportional to strain. E here is known as the elastic limit. This is the point at which the material will still be elastic, and such as say like a spring being stretched will go back to its original length. Okay, after point E, the material will behave with a plastic behavior, which will mean that the molecules, if you like, or the atoms, if it's a pure metal, will be permanently pulled past each other. Up to the elastic limit, they'll be pulled away from each other, but they can go back to their original positions. After E, they'll be pulled away from each other, and they won't return to the original limit. Point Y here, Y is known as the yield point. At the yield point, the material suddenly starts to stretch a lot with plastic deformation. In fact, you'll notice that the stress will decrease a bit. So it'll start to move a lot as the greater load, as the atom starts to stretch from each other. Okay. Then, as that happens, as with little stress, we get lots of strain. We ultimately get to the UTS, and the UTS stands for the ultimate tensile stress. Ultimate tensile stress. Okay, at that point there, that is, you know, it's the highest point there on the stress. That is the maximum stress that the material can withstand. And after the ultimate tensile stress, you notice the stress will decrease until eventually, as if you like, it stretches, the stress recorded decreases, and eventually it breaks at B, where B is known as the breaking point. Okay, so the material will break there. Okay.